Hello, everybody. We're here to talk to you about our Capstone project, and we're here specifically to talk about our patent relevant to our Capstone project. My name's Elijah.
My name is Christian.
My name is Kurt. I'm Louis.
And our Capstone project consists of flutter prediction on an aircraft wing. And flutter is basically when a aircraft travels at high velocity, eventually the aircraft wing starts oscillating and fluctuating. And we plan on using mathematics, physics, and engineering to predict this flutter prediction. And we plan on doing an experiment in a wind tunnel.
All right, so this is our specific patent that we chose. It's about the aircraft flutter testing device, and it's a United States patent created by these three beautiful individuals. Thank you. But right now, it expired in 1980, so there aren't any current assignees. But before that, it was owned by the U.S. Aviation Corporation. And we have an image on the right, which shows more details about how this works. And if we can go to the next slide, I think I can talk more about it. Yep. So the novelty of this specific patent is that it uses, it measures flutter without building like a massive structure that tests specimens. So what it does is it places sensors all around the surface of the aircraft. And when the aircraft flies, the sensors measure how much vibration is occurring. And that is what the patent is talking about, basically.
Yeah, and then some prior examples of these patents here is that here's the first one, which was in 1939. And this mainly focused on parts of the aircraft. And during this time, they were only able to do this for static testing, meaning that it was in static equilibrium and it wasn't moving. And these ones basically test the elasticity and deflection of the aircraft. So basically when a force is applied, it creates a bending moment and fluctuation. And that's how this test was conducted. But for this testing method, it doesn't account for vibrations in the flight, so that the aircraft, when it's traveling in the air, it doesn't really account for vibrations in the actual simulation, unlike our specified patent, which it does. And then our specified patent does use similar equipment that was mentioned in this patent article. And here was a picture on the right here that was also in the patent that we looked at from 1939.
So here's another piece of prior art, particularly this was a patent from 1944 that was on the excitation of vibration structural members. Essentially what it did is it defined a static test method to determine the torsional vibration characteristics of a structural member. So in simpler terms, essentially what it's doing is it's looking at the vibration response of, in this case, what it shows is an airfoil. And essentially the difference between this and our specified patent is that this particular patent didn't relate it to flutter. It just looked at what were the vibration characteristics of the airfoil or the wing. It didn't specify flutter as an issue. And our specific patent uses sensors that are based on or very similar to the equipment that is specified in this particular piece of prior art. So our last piece of prior art is the apparatus for testing aircraft. This was approved in 1947. So what this is doing is it's a stationary apparatus to load and measure elasticity and deflection of a member in tension or compression. This was done through the use of cables, pulleys, and dynamometers. And essentially what happened is the aircraft was suspended in the air. While it was considered to be a static form of testing in that the aircraft was not physically in flight, they were able to more accurately model the stress with the aircraft being elevated off the ground than it being stationary. And our particular patent uses these similar methods, only the difference is that ours would be in flight versus just being stationary and being elevated from the ground, if that makes sense. Our patent is essentially a mix of the three previous patents But what makes it novel is that up to this point, testing was only done on the ground versus our patent specifically mixed these three different prior arts into a cohesive package that could be installed on an aircraft, and the aircraft could be flown at different performance parameters, and Flutter could be evaluated at those different speeds and different altitudes and yes.
So the preferred embodiment of the patent is actually listed right before it discusses the claims. So the passage reads, "It is to be understood that the forms of the invention herein shown and described are to be taken as the preferred embodiments of the same, but various changes in the shape, size, and selection of the parts may be resorted to without departing from the spirit of the invention or the scope of the subjoined claims." So what this basically means is that as long as it accomplishes the same goal of actually testing the flutter and the vibration, and it can do it while it's in the air, which is the scope of the project and the spirit of the invention itself, it doesn't matter really what you use as long as you can accomplish those goals within a similar frame. And then that is reflected in the first claim of the patent, which you can see here. So it discusses the first claim of the test apparatus, and it says that in order to measure the bending of the flight surface about a first axis, it's going to use an electrically primed impulse forcing device. And it doesn't say really anything else about it. It just says where it has to be mounted in an antinodal region that is on an outboard extremes of the said flight surface. So this is deliberately vague based on the fact that, as said in the preferred embodiment, it does not matter what parts you use. All that matters is that it will in fact reach the goal that it set out to do. And in this case, as long as it is an electrically primed impulse forcing device and it is mounted in the antinodal region on the outboard extreme of the flight surface, it doesn't really care what you use as long as it accomplishes its goal.
Yeah, and that is our presentation of our patents related to our Capstone project of Flutter prediction. Here are our references. And thank you for watching.